This conference will now be recorded.
Excellent. Let me share my screen. Just share the whole screen. Yeah, welcome everyone. Thanks for joining the bi-weekly Dough Heat Exchanger call. Yeah, apologies in advance. I was not able to send out meeting minutes prior to the call. It was a really long weekend, and and yesterday was quite busy for me. But I do appreciate those of y'all who were able to make the call. And I think we can go over the material we have over here. I think we have enough folks who have joined the call. So just going over different areas line by line with regards to the 2023 OCP Global Summit. The abstracts are being reviewed by the cooling environments leads, and we have guidance from OCP to finalize the session selections by next Friday, which is the 17th of July. I believe the schedule would then be published on FNTech, and then the accept and reject emails to the speakers will be sent out the week of the 17th of July. And then once that is out, the draft presentations are due by the end of August. So I will definitely keep everyone posted. Keep everyone posted on how things are progressing over here. It seems like Benny is having trouble with sound. He can't hear anything. Can the rest of y'all hear me?
Yeah, no problem.
Yep, all good on my side.
Okay. I think you probably have to play with the settings. Yeah, let me send him something. Give me 1 second, guys. Settings for audio is under the clock. Okay. Yeah, and it also. Okay. Continuing on, just a few quick updates on the focus areas. So I did have an offline discussion with Carl and David from Implion. So we discussed some next steps for the modular data center plus hybrid cooling white paper. So David was suggesting that on the liquid cooled server side, we should use some actual data that might be available publicly. I believe they have some data based on the Leopard and Tioga Pass compute systems. I think that they have published before, so we're going to follow up on that next week. I'm also going to follow up internally with a colleague of mine who works on the OAI sub-project, where he kind of leads the cooling requirements area to see if there's any liquid cooling data that's been published as part of that, to see if we could use that as needed. So yeah. I also do have an outstanding action to follow up with Sankar now that he is back in the office, to discuss the next steps related to the aluminum microchannel heat exchanger white paper. Those are just a couple of quick updates I wanted to share. Um, I do have my colleague Jarrett Wyatt on the call, who's a mechanical engineer who's been working with Saket to kind of initialize the door heat exchanger frame for the facility. Um, I believe he has a preliminary concept he'd like to share briefly. And he also has a couple of questions for door heat exchanger suppliers. So, Jarrett, let me make you presenter.
My bad. I was muted this whole time. Thanks, John, for letting
Nice.
me go. Once you made me presenter and made me share my screen before I could unmute. So,
Yeah.
um, yeah, so I do have a few questions. Let me introduce myself first. This is the first time I'm on this call. My name is Jarrett Wyatt, and I work with John here at Meta on the Meth team. And I am a mechanical engineer. I've been working at Meta for a few years on mostly ML, AI projects, and of course in liquid cooling as well. And I have presented at OCP once before in the cooling environments track for the liquid cooling card, if anyone happens to see that. And so definitely excited to be here and work on this project. And I just wanted to get a few more details, I guess, about the design, about the community, maybe some of the standards that we're already using for some of these door heat exchangers, and to make sure that this frame design is essentially as applicable to as many, doors as possible. And so I have a few general questions here. I also have a very, very rough CAD design of what the frame might look like. That's open for feedback and some thoughts, but I did have some directed questions here, so feel free to stop me at any time to ask some more. So what I'll do first, actually, before I even show the presentation and the questions, is I'll just start by actually sharing the CAD. Give me 1 second. Um, Here it is. Uh, all right, 1 second. Let me let this go. Interesting.
Yeah.
Cancel.
Go to meetings takes a little getting used to, so take your time
Yeah,
getting it.
thank you. I appreciate it. Here it is. Uh, all right. Can you all see my screen? Can you see the cat?
Yep.
Awesome. All right. So again, this is very preliminary CAD. This is essentially just the frame design itself, showing a reference for the connection to the facility, which I'll talk about. This design here would utilize rails instead of fasteners like screws. And then also the frame design with the rack interface using some simple pins for a guide. And then, two standard holes for hinge locations. Just very general before I get too deep into the design. So just to start with this as a reference, the rack would mount on the front face. My apologies for not putting it into an assembly. And then also, I don't have much really CAD for the door heat exchanger, so there's nothing on the back, but there will be a volumetric to represent sitting above this face here. So the door will hinge at one of the corners here, and then it'll of course swing outwards above this plate. All right, let me share the presentation. All right. So I had some general questions, and then I had some specific questions that are for the frame and the door. This is specifically going to be geared towards either the rack interfaces between the frame and the rack, the facility interfaces between the frame and the facility, so concrete slab, and then interfaces between the door and the frame. So the first question I had here just generally were Is there a specific rack type that we're, focusing these door heat exchangers for? Is it, ORV3, ORV2, or 19-inch, 21-inch, or is it broad across all of the rack types that these are being designed for?
If I may say something, I don't know if this makes sense to develop a reactor for OpenRAC V2. Maybe from your side, like a customer Meta have interest to develop it for OpenRAC V2 because you have some data centers with OpenRAC V2. But for the future, I think makes sense to develop it for OpenRAC V3. There are some advantages using OpenRAC V3. Maybe the biggest one is because the dimensions, so the outside dimensions of the rack are pretty fixed, maybe change in the height, but not in the width. And if we are speaking about normal 19-inch rack, then you have to speak about the width 600 millimeters, 700 millimeters, 900 millimeters, 2 meters in the height, 2 meters 20, 40, whatever, and will be very complicated to develop a high amount of dimension, also types of reactors for this kind of racks. So I think is OpenRAC v3 is the easiest way to develop a standard reactor. And about the YOU, the standard for OpenRAC v3 is 44OU. So, but in the future, maybe another customers will use another high for these racks. But this is not too complicated to adapt it for another high if the other customers want to have a higher rack. It is easier to adapt it for these such a racks.
Thank you. That definitely makes sense. 1 second. I do assume and was assuming that ORV3 would be the rack type that I'd be designing for, as well as 21-inch as a standard, would start. Um, I just wanted to understand if there was, any desire for any others. Um, but that is perfect. And then I'm assuming 48 OU as well, with ORV3 being the standard. I don't know if 42 OU or 50 OU are as common that we're designing for as well.
Mm,
Yeah, I
John,
think with
correct me
ORV3,
if, sorry,
go
go
ahead,
ahead.
Vanka.
Yeah, correct me if I am wrong, but OpenRAC v3 have 44 OU, and this is the standard one.
Yeah, so it's
Uh,
you're right. So if I recall correctly, it's 44 OU or 48 RU.
Mhm.
yeah.
Yes, let me correct that
But
here.
Jared, I actually I agree with Juan Carlos, which is I think we can start by using the baseline ORV3, and then if certain customers want to adopt it for a taller rack, I think they can just modify it based on the baseline standard or design that you will contribute. So I think changing the height is, I mean, correct me if I'm wrong. I mean, you're the ME, but changing the height would probably just represent, um, um, I would assume, an easier modification of the or adjustment of the baseline.
Absolutely. It's just a range of dimensions to understand what the range would be.
And it's fine, right? And I think this is where as part of the exercise you can say, hey, here's the baseline OpenRAC v3 rack frame that we're using as reference over here, right? So we can sort of define that in terms of, here's the width and here's the height. I don't think the depth matters, because this is that's a dimension perpendicular to the frame, and in that case it could be 42 inches, 48 inches, really doesn't matter. um, but yeah, I mean, maybe that's something that we can start with. Yeah.
Perfect. That was actually my next question, was to ask about depth. Um, uh, is it so? So are you saying like depth doesn't necessarily need to be specifically defined from vendor to vendor? It can be a standard depth.
Um, yeah, so I think we have something along with regards to this published in the existing door heat exchanger requirements document. I know initially we had defined a reference point for the door itself not being deeper than a foot, and that had to do with the minimum hot aisle width. But I think in this case, considering that we're talking about a frame that's a part of the facility, I'm not entirely sure if we are chatting about a hot aisle containment over here. But um, I think at the end of the day, the requirement was the ability to open the door, to swing the door open at least 90 degrees when you have adjacent racks with door solutions as well. But the reference point that we had defined previously, which includes the frame, was 12 inches, or basically a foot. So, but now considering that the door is going to be separate from the frame, I think this is a great question to ask the vendors on the call to see what their thoughts are.
Sorry, John, the last question I didn't understand.
Yeah, I think John essentially was saying here, we do have to understand what the depth requirement would be for this frame, since it's separate
Okay.
of the door. And he mentioned that previously it was defined for a foot in the
Yeah,
about a
yeah.
foot, I believe, in the hot aisle. So he was saying, is there, any desire for that to change? Is there, a depth that is preferred, or that's essentially the question here.
Mm. Also, usually we don't need for a normal traditional rear door, we don't need adapter frame, but for sure for some application will be an adapter very helpful. Uh, um, for sure, it depends of the power of the rack. We will need a deeper rear door, so this adapter frame, um, which is part of the data center, should be not very deep, because this deep, these millimeters we lose will go, also will be maybe a problem for large applications. But I think 300 millimeters is enough.
But Juan Carlos, 300 millimeters is just the frame, right? Are you talking about 300 millimeters including the door?
Yeah, in our specification is the frame, also the adapter frame plus the rear door, 305 millimeters.
Yeah, I'm looking at it as well. 305 is what we defined. 1 foot. I think Jared's question is, if we just look at the frame itself, what should do we want to define a reference point in terms of how deep that should be, um, or do we want to define a range and say, hey, this would be dependent on how much power is in the rack, right? Because then that's a function of how much airflow is coming through the rack and so on and so forth. So does anyone
Yeah,
have? Yeah.
this is the problem. If the frame, if we have to 300 deep for the rear door and all millimeters deep the adapter frame have, will reduce the tip of the rear door. In that case, if for large application with more, I don't know how many kilowatts, but for large applications, we will have problems to develop the rear door if we reduce a lot the dip. Yeah. So,
Well,
but I cannot say now how much is the minimum and the maximum. Our range will be helpful for sure. Uh,
yeah, I think I do understand what's being said here. In regards to depth, I think a range would be best. What I'm thinking is, in that range, we can define like the maximum size of a door that would go with it. So if we're saying 300 millimeters, right? Like if you have a
yeah,
50 millimeter, frame, then you can go
yeah,
250 millimeters on the door, etc.
yeah,
So we can kind of figure out what makes the most sense. So I think I have what I need here. I appreciate that.
yeah. And also, it's maybe it's also important to define or give some ideas how to connect the rear door with the rack in case we are using air assisted unit. In that case, will be very helpful if we define some place here in the adapter frame to connect the rack with the rear door.
That is exactly the goal here. So I have the rack interface. Actually, I can talk about a little bit now. Is I think we answered this already, so we don't have to ask this question. Um, but essentially, the frame will interface with the rack and the door, so it'll define both. So I think using ORV3 as the reference for the rack interface would make sense, and then the depth can be a range. A question on gaskets. Is there any preference functionally if the gaskets between the door and the rack frame, is there a preference for it to be on either side or does it not matter? When I mean either
No,
side, I mean on the door side or on the frame
maybe
side.
we can put it in the door side, and then the vendors will decide which one is the right one. But I I have no preferences.
Yeah, I do.
The
I do think that would make sense.
only problem if we are using plastic or something like that, and we put it in the rear door, we have to apply it to UL or something like that. But this is nothing that we cannot solve.
It makes sense. I think I can define an area that the gasket must cover, and then the
Yeah,
vendors have to make sure it covers that amount,
yeah,
and it should be
right,
sufficient.
right. Yeah, this is
Okay.
important. And also let place for to bring the tubing and so on between the rack and the door.
Understood. Understood. Um, question about material. Does it matter? Is the material coated on the frame? Is there like a coating on the door or anything, or is it just regular steel, regular paints?
I think the best way maybe is to take the spec of the Open Rack V3 and use the same material and the same
Perfect.
surface.
Awesome. And then the last thing on the frame, and then I wanted to talk about the door, was just the fasteners. Is there any preference, or rather, is there an aversion to using like rails instead of, bolts and screws on the for to fasten the frame to the floor? Is there any, concern with using that, or is it okay? Was there a reason that bolts were chosen, is what I'm asking essentially.
I think we have to consider here if we put the rear door here in this frame, we have to think about the Open Rack V3 together with the rear door without this frame, and should be the rear door should be compatible with or without the frame, because in some cases customers are not using the frame as part of the data center. In that case, should be the rear door compatible with this frame. So another consideration, I don't know.
I understand what you mean. Yeah, I think that is a goal here.
Okay.
All right. So coming down to the door itself, I was curious in regards to weight. Is there any range of weight that's currently defined for the door, or is the door just, whatever weight it ends up being with the parts chosen?
Yeah, there is a maximal weight we have to consider. Let me find it.
Thank you.
Yeah, so in the requirements document, while Juan Carlos is checking, because I think it might be good for the vendors to also talk about what they have seen as part of products. But looking at the requirements document, we defined a maximum of 150 kilos wet. That's 150 kilos with fluid volume, and that also includes the frame. So I think it might be good to kind of have a number where we're just talking about the door only and not the frame. Anyone on the call have any thoughts based on their experience on the solution side?
Usually with them, we have something in the rear door to maintain the weight and not transmit the weight into the fastener. I don't know how to consider this point, but
Do you
for sure
mean?
the frame should be able to keep this torque and the weight of the rear door. But usually, like I said, we put the weight of the rear door on the floor and not on the fastener.
I understand. So like the hinge goes all the way to the floor.
Yeah, this is the best way. No?
Yeah, that makes sense. That makes sense. Um, okay. And then this kind of answers that question's answered as well. Um, food. Um, Where it's coming to the back type, it's server. Okay, we talked about this a little bit. ORV3 as reference. So hose routing. I believe you mentioned this a little bit earlier. In regards to hose routing, I've only seen one or two rear door heat exchanger designs, and I noticed that the hoses might route over the fan array on the inside of the door facing the rack. Um, is there a reason that it was routed exactly over the fan array? Is there a benefit to doing that, or was that just the easiest way to route it?
Could you repeat the question? I didn't understood good.
I guess is there a preference in how the hoses are routed for these doors?
Yeah, usually the hoses or the connections to the rear door goes through the rear door from the top or from the bottom. Uh, Also, you have not to consider the frame in that case, but I am speaking about the traditional one. In case we speak about the air assisted unit, we have to consider the road for the piping through the frame or in some way. So in that case, we have to consider this route for the piping. In case we are speaking about the hybrid solution, um, depend how we are working or which if the rear door is working in series with the CDU or with the, the liquid cooling system or is working in parallel with the CDU, then we have to figure out how to put the connect of the hoses through the frame into the rack because the open rack V3 have not um, um, a place on the base of the rear door. There are no place to put the hoses through the base of the rear door. There are no holes or something like that. So this frame should consider also place to bring the hoses through the frame into the manifolds, something like that.
Absolutely. That's exactly the goal here. And I was curious if I think that just putting like maybe two QDs at the top of the door would just be the easiest way to do that. So you can just route the hoses either through the frame or from the facility or however you're supplying,
Yeah.
coolant. You can just have the connections at the top of the door defined that way, and it's up to, whoever
But
the
also from that button, no? I don't know if you are developing for Meta. I don't know if you have on the floor piping, but a lot of customers have such a floor systems, and the hoses route will go through the floor.
Yeah, I think on this one, Juan Carlos, I think the way the frame is being defined, I think the assumption is that we're talking about concrete slab. So in that case, the connections probably are only going to come from the top.
Yeah.
Um,
Okay.
I'm not entire. I mean, and I think I'm sharing this just to hear what you guys have to say because you all have so much more experience than us Meta folks do with like deploying liquid cool hardware. Um, but the assumption would be is if you had underflow piping, then it would make more sense to have the door mounted directly to the rack. I think creating a frame that mounts to the facility probably makes more sense when you have a concrete slab type of facility. So I think that's where kind of our thought process is coming from. Does that make sense?
What is the reason why? Because the biggest advantage to keep the rear door in the data center is if you want to change the servers, the rack, you can change the rack, but not the rear door. And this argument is the same if you have a rise floor or the water is coming from the top.
Okay, so yeah, because I mean, this is a conversation that Jarrett and I had with our colleague Saket yesterday. Because like one question I had was, in terms of how facilities are trending moving forward, is race flow still a thing, or are most of the hyperscalers or most of the large providers moving to concrete slab? And I guess the thought was, there's a pretty strong shift to concrete slab, but I think if we had to make this frame work with the race floor, I think Jared would probably require some guidance from the folks on the community call to help us understand how that could be accommodated. Because I
Yeah,
feel like the design for concrete slab and the design for race flow might be visibly different from each other. But I think that's where we'll probably require guidance from the community over here based on their experience.
yeah.
I mean, do any of the vendors here, do you have doors that have hoses, like I guess QDs on the bottom and hoses on the
Yeah,
bottom? That's where you connect?
most of
Yeah.
Yeah,
them, most
we
of
Okay.
do.
them. Yeah,
Okay. So bottom and then top. Okay. So I mean, there also one thing I was thinking of is there could be, more than one iteration or version of this frame, right? To either meet a different type of facility. The one that I showed earlier, the image, is more so to mount it to the concrete slab. But I've seen other frames that don't necessarily have to, you know, take up that same range of space, etc. But I do understand what you guys are saying here, and I think that can be implemented. Just some flexibility in hose routing. And the last question I had was on handles. Would there even be a preference to define where the handle is? Because on the frame, I can make a hinge that the door, the handle would just connect to, so it can just be predefined. Would that be something, vendors would even want, or do you want the ability to just flexibly put your handle wherever you want, I guess?
You mean for the handle swinging open, or for the door to
Uh,
swing open?
yeah,
yeah,
literally the latch, like when you attach the door back to the frame, right? Like the latch that, locks it shut.
yeah,
Oh,
yeah. You can open that from the right or from the left, and depending how is where is the exit of this row, you have to consider it, because you cannot close the corridor outside this row maybe, and therefore you have to consider both cases if you want to deliver to every customer.
Understood. Understood. I pulled up the CAD here just to also give a reference. What I'm essentially saying is to define maybe, a range maybe from here to here that says this is where the hinge will be for the door on both sides, right? So that
Oh, well,
means that
like
Yeah,
a
you have
height.
to put your handle in this area, like the height, exactly. Um, I just wasn't sure if that's something that would be uh more complicated for vendors than helpful.
yeah, we have to consider it. Not all customers are opening the rear door from one side.
Yeah, as far as that height goes, I'm not sure that's I don't know, that's a good question. I don't know off the top of my head. I'd have to look into that. But I don't think
Fair
that's
enough.
a big deal for us to adjust the height of that handle.
Okay. Cool, cool, cool. I can take that into consideration. That can be an ongoing conversation. Plus it's relatively easy to,
Right.
openly define that. So, all right. Those were essentially all of my questions that I had here. Um, I wasn't sure if anyone had any questions for me, but I really do appreciate all the insight and the information you guys had.
As far as the weight goes, right, for a facility RDHX, I guess the only two options would be to have it on the concrete slab, as you say, or suspend it from the structure. So I was just wondering, when we say a weight limit of 150, and I know that that's the feedback you got from us, but that 150 kilograms when it's full of fluid, that is for like a typical door that's supported, I guess, on the hinges for the hinges of an existing rack, plus I guess wheels at the bottom. But in this case, if you have a concrete slab, um, the weight limit could be much higher, right? So I just want to make
Yeah.
sure, I guess, that when we say 150, we're not like overly restricting ourselves based on um, a load limit that it doesn't apply in this case.
Yeah,
Yeah,
I think
I
that's
think
fair
that's a really
point.
good point.
Yeah, I
That's
think
right.
that's a
That
fair
makes a lot of
point,
sense.
but I think that's where, sorry, Jared, I think that's where we need to ask the suppliers, right? I guess Benny, Mike, Juan Carlos, like how heavy can a door get, right? So because that would factor into how sturdy the frame would need to be, right? So I think it'll be good to have a sort of reference point that Jared can work with.
Yeah, I mean, I have a list of different weights here for doors. I know not one of our doors, but there's a competitor door. Their wet weight is up to 406 pounds, which is pretty
Wow.
heavy.
Yeah.
And it's not a standard. That's not common. That's definitely at the higher end. But that's yeah, 185 kilos right there. So. But normally, like we said, I think 150 at 330 pounds or less. That that's much more common. That's the common weight that I see doors at from not only uh, Vertiv but from our competitors as well.
I think what you might end up having to do,
Pretty or less.
Jared, is stop. Sorry, I didn't know. I thought you were done on. I'm sorry.
No, I'm done. Go ahead.
I think what we may end up having to do, because I was kind of looking on the side here, trying to form a parallel with some of the work I've done. You may have to just start with the 150 and then talk to a structural engineer, because when you start talking about supporting weights or loads inside a building, you have to do something called live loads and PSI ratings, and that's more a structural engineer's function. Um, so I guess yeah, you can get the feedback, from the suppliers, and then once you have the model done and you get the weight, then you can probably talk to a structural engineer to see, well, if I attach it from the structure or from onto a concrete slab, like what are the limits I'm looking at from that perspective?
I do appreciate that. I think that's a really good idea to figure out what that weight limit is on the, data center side, the facility level, to understand really what weight limit can be supported by the frame and by the building, because there are different limits, of course, just to the ground. It does sink. Um, uh, I think knowing that 406 is a little bit higher up, I can see what the frame can support. I'm gonna have to do some FEA. So what I can do is figure out what the standard frame design can support on its own, and then talk to, some of the data center team, figure out what the weight limits for a hall are, like for a row, I guess, and then just kind of, bring those to the team just to help inform myself as well on what the limits should be on this frame.
Yeah, sounds
Appreciate
good.
it.
I'm sure Saket can help with reference point for concrete slab. And they can also tell us what's possible with the race flow. And we can always bring that information back here and have it verified and reviewed.
For sure, for sure. Appreciate it. Thanks, everybody.
Okay, let's go back to the agenda. Jabari, not to put you on the spot, but I did respond to your email about concurrent maintainability yesterday evening, so I didn't give you much of a heads up, but um, you know,
So
uh,
Rob did not recall.
yeah, I think you had two questions. I think one of them had to do with just general, do the facility folks, have responsibility of maintaining the cooling components? And I think on that one, Saurabh, being a part of the systems integration engineering team, will be able to answer that. I think your other question about like what are the typical maintenance procedures for RDHX installations? I'll be honest with you. Meta doesn't have any door heat exchanger deployments, not yet. So we don't necessarily have any answers here. I'm wondering if this might be better posed to the community over here, um, to see if we can get some answers over here on the call.
Yeah, Jabari, you sent us this question in an email, and we talked about it internally for the maintenance and repairs. Uh, that we it's pretty minimal as far as maintenance goes. We do like check the heat exchanger for pollution, for dust, etc. Functionality of the valves, and then check the chilled water system for leaks as a visual check. But then some of our customers, they have it required that each system has a maintenance procedure, and so we have like a little checklist for someone to go and just do those few things. Check wiring for that on the fans for the controls. But it's pretty low maintenance. Nothing is required to you're not required to shut down any equipment. You wouldn't need to do that unless you had to do like a real repair or something if something was broken. But for maintenance, it's fairly minimal. And also the other question you had asked in the email was regarding, where does the um, responsibility start and stop for the for facility versus IT. It's Vertiv Stansted. Everything that's outside of that server, from the hose whip to the CDU or to the chiller, really, is a facility um,
So
issue.
basically,
So
anything beyond the L11 is a part of the facility, is what if I'm understanding correctly?
Yeah, anything beyond that server, where as soon as you have to go into that server, that's an IT issue. But
Okay.
anything before the server, from the chiller up to the hose whip that's connecting the manifold to the server. So that would include the hose whip, the in-rack manifold, uh, a secondary fluid network, CDU, etc. That would be a
Okay,
facility issue.
up to the
Yeah,
manifold. Okay.
yeah.
I guess in the meeting from previous to this, because we had a couple heat exchanger guys on there. They kind of stopped at the rear door. I guess the question I'd ask you is, what if there is a cold plate and an internal CDU? Does it include the cold plate, or is the cold plate more the IT team?
No, the cold plate would be for the IT team.
Okay, so manifold, and once it crosses into the server, all right, understood.
Yeah, I am
Um,
with Benny as well. I think the wall of the servers there and the maintenance, because we cannot open the servers. You have to remove the server to open the to repair the
Right.
cold plate, something like that. It's not our part of the data center. It's part of the IT gear. Therefore, I think as well that the maintenance end in the server,
Yeah,
the
exactly.
okay,
outside face of the server.
I think everyone's kind of falling into that. Yeah, I think we're all in agreement based on all the discussions that we've had as to where that boundary is going to be. With the cold plate group, it was a much more involved discussion.
Yeah,
I guess I'm just going back to your previous discussion when you're talking about maintenance. So you mentioned a couple of things like making dust and stuff on the heat exchanger, checking for leaks. If the temperature, because in the previous call, John Gross mentioned that if the temperature control valve malfunctions, you actually need to have, not in the previous call, for concurrent maintainability. John Gross mentioned that if the temperature control valve malfunctions, you may have to do a shutdown, like you won't be able to do that repair online. So is that a typical maintenance procedure that you see in the deployments of a radar heat exchanger?
No, it hasn't been. I haven't seen that to be typical um, for the control valve malfunctioning. But
Where have you
I
seen
see
the
why it
control
says
valve
that.
deployed usually? Sorry,
I'm sorry, say that again.
the control valve. Where do you typically see it deployed at? In what area? Um,
I guess Jabari's question is, would you have like a PICV? Um, would you have a PICV per door to kind of um, like for example, maybe you wanna control the flow rate so that you don't have excessive condensation, right? If the loads are really low and you're using chilled water, then you'd want to slow the flow of water to the door, or maybe even shut it down so you don't have excessive condensation in the coil or something like that. Jabari,
Sure.
are you referring to that component, like
yeah,
the
that,
modulating valve?
yeah. But you were a lot more eloquent than I was. But yeah, that's what I was trying to say.
I think the question would be is would you have it in a one-to-one relationship, right? Meaning, is it usual to have a PICV per or some sort of control valve per door? And I guess this is a question to
yeah.
all the
Also,
all the
you
solution
are
providers.
speaking about the valve of the to control the flow of the rear door. Do you?
Yeah,
The
Yeah,
RCB? Yeah. Okay. Okay. Yeah. No, usually, if you want to control the air temperature, you need a valve, something like that. So in that case, um, this is nice to have, I think, to be able to change something of the valve. For sure, it's not usual that the valve get down, but if in case the part is going down, is the motor, not the valve. So maybe it's one point to consider to be able to remove the motor and not all the valve.
Got it. So
Okay,
the
so
electrically actuated part is more likely to fail here. Got it.
Yeah, yeah. Like Martin said before in the meeting, yeah, there is another solutions to change the valve without shut down the reactor. But this is a special customized system, so I don't know if we have to consider that point like a standard for LCP or something like that. I speaking about the bypass from before, Jabari.
yeah. I figured. So yeah, we did speak about the bypass um, from result perspective. So in the case of a control valve, where you, to avoid having to shut down the unit, you'll do a bypass and just have full flow going through the unit while you repair the valve for like a short period of time. And this, of course, is just to maintain the feature of concurrent maintainability in your system, right? That's why, for a short, if it's temporary, then, it should be fine. And we were just talking about, what would make up for that loss in cooling on the facility. That's where the bypass came in, just as a background. One more question. So, from Vertiv's perspective, right? CFD models, when you all are doing the new installation, like, do you do CFD models for just the rack that you're working on, or do you take the room or the facility into account? And this is just to look at different failure modes and stuff. For instance, if you have to take a rack offline, does Vertiv look at the different impacts that would have if you take one rack or two racks offline and you lose that cooling capacity? What kind of impact they're going to have in the room? Is that something that you will do as well? Sorry, that was the Benny. I don't know if you heard. I know you were having trouble with sound.
Yeah, we answered this question before.
Yeah. So that was the Benny. This was the one.
Yeah, okay.
That's why I said
Okay,
with it.
okay. So for summing up your question, if you have to take one or two of the racks offline, how will that affect the rest of the room?
Well, does Vertiv do like CFD models to look at failure mode? To say, well, okay, well, if you take one rack offline, you're going to get a hotspot here, or you're going to get recirculation into these adjacent racks, and it's going to spike the inlet air temperature, that kind of stuff.
I don't know the answer to that. I would think I don't know the answer to that.
Okay.
My assumption would be, Jabari, is that's kind of like case by case, to be honest. I would say if Meta ever if Meta did consider this technology, that would be one area that we would assess with our systems engineering team that does a lot of CFD, but at the data center level. But I think it also
Okay.
depends on multiple factors, right? It's like how many racks, right? First of all, have door heat exchangers. Then the other thing is, how much power is actually being dissipated, is being captured by the door. Because if it's not significant, then like how there's general guidance that, hey, if your rack power is less than 4 kilowatts, you don't really need hot aisle containment, right?
Yeah.
So there are so many factors that that matter here. But I'm just curious. I mean, like, instead of asking if CFD modeling is necessary, because I feel like this is, you guys are kind of, I mean, this is just my take. I've not been on the calls, but this is kind of one of those questions when you start getting into the weeds. I don't mean to be mean here, but I think maybe you can just address it by putting in a comment saying, you know, the impact of taking a couple of doors down for maintenance on the remaining racks is probably something that could be evaluated by the end user and the, or the integrator and the facility folks. And CFD modeling could be one avenue to do that. Just keep it general.
Yeah, definitely. So the context of the question was, I just wanted to know what different people do, and it was just to get feedback, right? So it wasn't to say, well, hey, this is the right way or this is the wrong way, or it was just to say, well, liquid cooling is new. Different people will have different experiences with successful deployments.
That's true.
And
That's
this
true.
is what we would have done in the past, and it was and CFD came up just because and this was a comparison that John Gross made as well. When you talk about radar heat exchangers, you can essentially model it as a bunch of small air handler units, and kind of consider it like saying, okay, if this CRA goes down, what is the impact on this space? And it's a very similar exercise that you would do for a totally air-cooled deployment, right? So that's why I referenced CFD, because it's so typical in air-cooled deployment that when you look at radar heat exchangers, it might be something that people would do fairly commonly. So that's where it came from.
Yeah, and I think also, and I know we're kind of two minutes over. We should probably close this call pretty soon.
Yeah.
Door heat exchangers have been around thankfully have been around for many years, many decades actually, and I'm sure there is some analysis that's been conducted and published as part of conferences like iTherm, SemiTherm, or Interpack. So maybe that's something that could be referenced, right, as part of this is, here's an example of like CFD analysis, or just talk about CFD analysis as being an avenue to, to understand the risks in general. Yeah.
Okay. Yeah. Yep. But thanks so much, Benny, for the feedback, and thanks for making those notes, John.
Yep. It's over here in the meeting notes.
I'm on it. Yeah. Thank
you. Okay. So apologies, but I think I need to cut this short. I did have another item, but it did say as time permits, so it seems like we had a good discussion today. Thanks all for joining today's call, and hope you have a good rest of the week, and see you all in 2 weeks. Thanks all.
Okay. Thank you, you too. Bye-bye.
Thank you. Have a good week.